Hi everyone, today we're going to be solving the HMMT 2019 Algebra and Number Theory Problem 4. So the problem states, suppose that P of XYZ is a homogeneous degree 4 polynomial in three variables such that P of ABC is equal to P of BCA and P of AAB is equal to 0 for all real A, B, and C. If P of 1, 2, and 3 is equal to 1, compute P of 2, 4, and 8. Okay, so this is relatively more difficult than the previous three problems. And as in the HMMT, there are 10 problems for each individual test. And as you go on, the first three problems or so are like mid to hard Amy level questions. And now, from the fourth problem, it's hard Amy, and it gets even harder and harder as we go on. But this one should be doable. So remember how it said that P of A, and B is equal to 0. So by this, we know that x minus y is is divisible by P of x, y, and z because a minus a is equal to 0, which is divisible by 0, because these are the same when you get a 0. So therefore, x minus y must be divisible by, it must be a divisor of P of x, y, and z. And as stated before, P of x, y, z, well, it said P of A, B, C is equal to P of B, C, A, which in turn is equal to P of, so these two must change. So it would be P of C, A, B again, okay? So just something to keep in mind. Therefore, that means that x minus y and also y minus z, but also z minus x. Oops, z z minus x because c and a correspond to that. So it would be y z x is equal to p of z x y. Okay, so that means that these are all divisors of p of x, y, and z. So let's just keep these in mind. And we want to find the p of when we have the three variables x, y, z equaling to 2, 4, and 8. So we want to find p of 2, 4, and 8. But let's just erase this really quickly. So remember how p of x, y, and z is a degree 4 polynomial. So therefore, if we were to divide that by these three, we would get a symmetric, that keep that in mind. It has to be symmetric because you're dividing it by all of its, most of its factors. Symmetric degree 1 polynomial, which is of the form k x plus y plus z, the three variables from inside. It has to be k, and there has to be some value k because that is the coefficient. Okay? So we have to find k. That's one of the parts of the problem to finding the polynomial itself. So this is equal to p of x, y, z over x minus y times y minus z times z minus x. So that is what we have. Now we're going to just write a quick equality of the ratio of P248 and P123 because so we want to find P of 2, 4, and 8. But we already know that P of 1, 2, and 3 is equal to 1. So this, we can write the equality in a ratio like so. 1, 2, and 3. And because these four are all factors of this polynomial, we can rewrite this as x, y, and z are 2 plus 4 plus 8, but don't forget that k in the beginning. But we have because it's the same polynomial, we have the same k, so these factors cancel out. So here we have 1 plus 2 plus 3, and then we have 2 minus 4, and then we have 4 minus 8, and then 8 minus 2. And then on here we have 1 minus 2, 2 minus 3, 3 minus 1. So this would be negative 1, that's a positive 2. Negative 1, this is a negative 1, so these cancel out. It's just a 2 times 6, which is equal to 12. But we know that p of 1, 2, 3 is equal to 1. So that means that k must be equal to 1 over 12 to neutralize this 12. So we just have to find this above, and then we just have to multiply by 1 over 12, and then we get our p of 248. Otherwise, you could have just canceled these k's and moved along, and then just do the whole division. But I think that this might be a little easier. So we have 14 times negative 2, negative 4, and then 6, that's equal to 48, positive 48. And then that times 1 over 12, that makes this a 4 times 14 equal to 56. And therefore, we have our answer, p of 248 is equal to 56. And that is the end of this problem. So it started out as a pretty hard problem, but as we were able to find the similarities and use that p of AAB is equal to 0 to get these three factors of our polynomial, and then we came up with our degree one. We could have done without this k, by the way, because anyways it was going to cancel out. But it's just good to know that k was there. There has to be some factor involved. And then we could have just solved 248 times 2 minus 4 times 4 minus 8 times 8 minus 2 over 6 times 2, 12, and then we would have got 456 as well. It would have been the same answer. But in this way, we were able to utilize the powers of polynomials. No pun intended. Okay, so thank you for watching and have a nice day.